This is given problem. Design an NFA that accepts binary strings that ends with either 0 or 1. First we understand the question, then we have to write the language. Okay. So what is actually language? Yeah. First we will start with minimum length 0. They are giving either 0 or 1. Okay. Zero and 1. And all possible combination we have to write. At least 10 strings you have to write and check whether it is supported by the NFA or not. Okay. And this is also possible. 000 also, because it's end with either 0 or 1. Okay. So this is end with 0. Another possibility is 4 also possible. Okay. 6 also, n also possible, but ended with 1. Like that, we have to first write the language. It's also possible. Ended with 10 and 1100 ended with 10, and n number of zeros also. Okay. So like that, first we derive the language from the given problem. Okay. And try to, next step, we are going to draw the NFA starting with initial state Q0. Okay. So here initially we are having either only 10 and 11. Fine. Again we have to check all the string. Okay. Either this machine start with 0 or 1. Maximum possibilities, because we are having this binary strings either 0 or 1. Okay. And we are having only 10 consider this string, so it may be ended. So that's why I make it as a final state, because we are having only 10. Start with 0, end with. Okay, we are having the path. And concern the second string, we need 2 ones at least. Okay, so that I'm just introducing one more state 1, and I make it as a final state, because we need 1. Yes, here 1. We are having the path starting with 1, ending with 1. Okay. So consider this 2 string, it is valid, checked by the machine also. Okay. Again it check. 30 also we need to draw. Okay. It's also supported by the machine. Okay. So we are having 10. What about 20? You can make it as a loop also. So loop means it will pump either empty or any number of zeros. Okay. Now we check. Start with 0 and again 0 and again 0. So it's also final state. So we are having the path for 000 also. And again you have to check the fourth string 4 1. So now we are having 1 1 2 1. We need again 2 1. So there is no path here. So again you may introduce the loop 1 maybe. So what is the answer now? 1 1, any number of 1. Okay. Now we are getting 4 1 also. This also valid. Next we check 0 0 1 0. So now we are having 0, 0, okay, but we don't have 1, so we just to make it as, just give the connection, you make it as a 1, maybe you are getting, you see, 0, 0, 1, but again still we are not having the 0, so you make it as a loop, self loop we can say. Now we check 0, 0, 1, 0. It is a final state. So this path also, valid path, it is also accepted. Next you check 1, 1, 0, 0. 1, 1. So there is no 0. You mainly introduce here the loop 0. Okay. Now we are getting 1, 1, 0, 0. It is also accepting state. So the NFA has more than one final state. And n number of zeros, it may be here 5 zeros. 1, second 0, third 0, 4 0, 5 0, and 1, 1, 0. Okay. So like that, while creating the design, we can ensure it will support all kind of strings derived by the machine, derived by the given constraints. Okay, so this is a way of designing the NFA. So while using the input, while making a transition from starting state to another state, we have to ensure it will support for all kind of the string. So this is a way of designing the NFA. So now we will make it as a transition diagram, Q0, transition table, sorry, starting state Q0, Q1, Q2, Q3. This is a final state. Q1 also final state. You make it as a star. Then as it is 0 cents 1. You fill the table column. Yeah. So what is a Q0 0, Q1, and Q0 1, Q2. Then Q1 0, Q1, yes, Q1 1, Q2, Q2 1, Q3, then Q2, Q2 0, yeah, Q2 0 again Q1, sorry. Yeah, Q2 0, Q1, then Q2 1, Q3, then Q3 0, Q3, then Q3. Okay. So this is your transition table. Using the table also, we can check whether the string is accepted by the NFA or not. So now I will check only small string, that is still not of Q0, comma 1, 1. So what is the transition for Q0 of 1? Q0 of 1 means you are getting Q2, comma 1. What is Q2, comma 1? We are getting Q3. So we are reaching the final state, hence this string is accepted by the machine. So this is a way of checking the string whether it is accepted or not by the created machine. Okay, so we can say this is a transition function that is called a delta. So here in this way we are designing the NFA. Thank you.